just some of the design considerations you need to think about if you're planning on deploying SharePoint on IaaS. There are other sessions at the conference. Victor Whelan's got a session coming up that he'll go into much more detail about how to do specifically scripted deployments and how to look at things like Resource Manager and PowerShell integration. We're going to touch a little bit on that concept, but this is kind of really the first step into that overall guidance piece. And this still isn't working. So just to give you a bit of intro, I'll let Bob introduce himself.
Yes, I'm Bob Fox. I've been a Microsoft PFE. You guys familiar with Premier Field Engineers? So, with the CritSit boys. I'm now working the BRE team, which is the beta team, supporting our internal and tab customers.
Okay, cheers, Bob. My name is Neil Hodgkinson. I'm a program manager in the Office 365 team, the product engineering team for SharePoint and Office 365 and OneDrive. I'm formerly a PFE, about just approaching up to 10 years in Microsoft now as a field engineer and an escalation engineer. So as I said already, the things we're going to cover is really about what about, in some cases, it's actually going to be why not IaaS, right? It's not always the best decision to make. So we're going to touch on things like, why not Office 365? You know, Office 365, you know, this is the Office 365 track, and Office 365 is a major kind of marketplace for Microsoft in terms of deploying our solutions and having our customers deploying to Office 365. We're going to look at why you wouldn't necessarily use that. What's IaaS? We're going to look at machine SKUs and how IaaS is actually built. And what happens when you click that little button that says deploy VM? What goes on behind the scenes to register that VM with your tenancy and make all that kind of wiring work? Through to the various machine SKUs, and I'm sure you're aware, you've all played with, has everyone played with IaaS in Azure or various ways? Some have, some haven't. You'll have noticed recently that the number of SKUs available to you as we kind of open up the premium SKU capabilities and start adding things like the premium storage and the D machines and the G machines and the DS machines, a whole world of different types of machines, and it gets quite complicated when you start to look at them. So we're going to look a little bit at those. We'll also look at storage, specifically thinking about the SharePoint world, where one of the things we need from our storage is performance. Bad performance on your storage layer basically means pain for everybody, both the admin and the end user. We'll look at briefly at networks in terms of separation. Bob will go into a little more detail there. And then Bob will cover off some kind of SharePoint specifics, which leads into the sessions following this with Victor and his resource manager stuff. I guess the key message about Office 365 is we're pushing Office 365 as a product. From a marketing standpoint, from a technical standpoint with Microsoft, if you can do it in Office 365, we would suggest you don't use Azure IaaS. Okay? Azure IaaS is going to cost you a lot more money. It's a lot more complicated. So from a workload capability perspective, if you're thinking about basic collaboration, if you're thinking about OneDrive style personal storage spaces, Azure IaaS is not the place to be doing that. Azure IaaS is where you might deploy complex scenarios and complex line of business applications. So think about that in terms of when your users are looking for a basic collaboration solution, just try and think Office 365 first. Anyway, that's the marketing done. Finish with that. When it isn't an option, this is generally why. So server-side solutions, full trust code, there's lots of sessions this week talking about converting full trust code to the various app models, CAM models, whatever you want to call them. And generally, if you're in the world today where full trust code is a requirement for you, there are things you simply cannot do with the various app models or investments you've made in products and solutions that you've purchased and you want to get them to end of life before you try and redevelop them to do something else, then IaaS might be an option for you. Things like data sizing, Office 365, recently we've announced, the concept of the 1 terabyte OneDrive and the unlimited number of site collections, but data size might still be an issue for you in terms of general migration, perhaps. Anyone's tried to migrate to Office 365, we're improving things, but over the past couple of years, that migration's not been the easiest thing to do. At 3 o'clock this afternoon, there's a great session by Kimo on migrating data to the cloud. But data size could be a problem. With Azure, I want to migrate my SharePoint site to Azure, and I've got 50 terabytes of data. How do I get it there? I just put it all in a van on encrypted disks and ship it all up to an Azure data center. Nice and easy. I never underestimate the bandwidth of a UPS van. It's that kind of scenario. The other thing is, what about my on-prem farms? If I'm thinking about downsizing my on-prem estate, then Azure IaaS might be the right thing to do. So I want to think about taking some of those key workloads out and pushing them somewhere else, where someone else takes care of the host machine patching, someone else takes care of the networking, someone else takes care of that kind of thing. So it's a delicate, fine balance between whether I use Office 365, whether I go IaaS, whether indeed I stay on-prem. And these are just the things you need to think about. Don't just go with this kind of all-out rush, mad rush to IaaS and get it all wrong, right? So that's the kind of message we want to give here. Thinking about what we can do, so Azure IaaS for SharePoint. Some of you will see, and we're going to show some bits and pieces in a few minutes about how we can easily spin up SharePoint farms. You know, Scott Guthrie did the presentation at World Partner Conference about how you can do the few click buttons to build the SharePoint farm, and we'll show you that process if you haven't seen it. It's an easy way to build a SharePoint farm. It's not an easy way to build a SharePoint solution that's going to work for you, your customers, and yourselves. So we're going to talk to that in a few minutes. But fundamentally, if you want to put SharePoint on IaaS, you can make it work. It will work. But you need to think about the things we're going to cover off now. So those of you that have done IaaS, I need to stand here. When you think about infrastructure as a service and what IaaS actually is, there's basically three components: storage, compute, and network. Network, how do I connect my things together? How do I connect them to the outside world? How do I connect them to other services, either inside Azure or outside Azure? The compute power, how much horsepower do I need? There's machines inside Azure today that far outstrip most of the things you can buy off the shelf. Right? How much would a HP or a Dell or any other favorite vendor provider of server with kind of 64 cores and 600 gigs of RAM going to cost you off the shelf? Right? We can deploy those kind of things in IaaS. It's dead easy. Right? When we're going to talk about the price it will cost you though in a few minutes, and you'll see what that is. Then think about the storage layer. Okay, storage on premises, thinking about SANs, thinking about direct attached storage, thinking about NASes, all those kind of things you have to think about. In IaaS, it's much the same. There's a ton of storage up there and different ways to consume it. And again, we'll cover off that. But when we think overall about IaaS, those of you that have deployed IaaS solutions, it isn't easy, right? I'm going to let this build out since I have to click this keyboard. We'll stop there. So all those things, sorry if you can't read them at the back, you need to think about. When we're thinking about networking, how do we connect to things? So again, thinking about connecting to on-premises, thinking about site-to-site VPN, point-to-site VPN. What about express route, those new things we've all added in recently? Compute power, what about a reboot? I talked to a customer literally late last week who planned that they were building their IaaS infrastructure, and they loved the fact that the temporary disk on their IaaS machines was fast. So they were going to put their search indexes on there. Those of you that know IaaS know that every time you reboot a machine in IaaS, what happens to your temporary disk? Right, we flush it, it's gone, gets reassigned. So they were going to put their search indexes on there. So they hadn't thought through the solution. They needed to think about something different. And then when we come to looking at the storage side of things, thinking about how we deploy, what kind of storage we can use. Do we go direct Azure disk? Do we use persistent SSDs? Do we look at using the temp storage for some things? Again, we'll cover off things you can use it for. And then replication. My storage in IaaS supports a number of methods of replication. Local replication, zone level replication, geo replication. What's the right choice for you? There's all these things to think about. It isn't just a case of loading up the wizard that will show you and spinning up a machine. This is going to, come on. Okay. So when you think about what the actual Azure and what Azure means in terms of Microsoft and SharePoint and generally products in general, we're really thinking about the concept of what we call the Cloud OS. So people think about Azure and they think, oh, Azure's just a hosting platform, and I can build some VMs in there, and I can talk to them VMs, and I can put them together, and I can publish them out through endpoints. Azure itself is actually a complete operating system. Okay, it was designed as an operating system back in like 2005 when we first spun the thing up. It's actually a dedicated platform. Okay, it runs a lot of general core Microsoft stuff behind the scenes. The key thing we're thinking about when we think about IaaS and Azure generally is these kind of three core pillars. So getting your data, think about the features that sorry about this. Think about the features that IaaS has or Azure has about how to provide data access, provide people access, and then the concept of modern apps. So we're really talking more kind of outside of IaaS right now in terms of the Azure AD and publishing those kind of things. And really this was a kind of a setting the scene slide. So I'm going to let Bob walk through a demo of just a couple of ways to spin up VMs and see how that goes. So hopefully the resolution will be okay.
Come up. Come on.
My Nick's playing up, I think. Yep.
One sec. What's wrong with your machine?
There you go. Just refresh that. There you go.
All right.
You see that? So the screen resolution's not the best, but
So we're just going to build out a simple machine real quick. Have you guys all done this? Yeah? All right.
can I ask another question? Has anyone not done this? It's good, there's a few.
Oh,
Okay.
perfect. All right. Very, very simple to do this. All right, so we click on New. We choose Virtual Machines. Come on. Yeah, your nick is... 1 second.
I don't think my machine liked being moved between rooms.
Nope. Let's try this again. There we go. All right, so we can choose from the Quick Create, and I'll show you that. All right, so we're basically just going to enter some information inside here, push next, 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 we're good. Typically what guys are going to do, or folks are going to do, is go from the gallery. So here we're going to choose an image. All right, grab 2012. What is wrong with you? There it is.
It's the resolution, you might want to just shrink that a bit. Make it like 75, let's see.
Come on. Can you guys still see that? That's like
Yeah.
switching over. There it is. All right, so we choose our OS, bring it across, next. We should have done this in the speaker room.
So those of you that have done this know it
There it
works,
is.
right? Nice working.
All right, so next we go to the tier. All right, so what do we choose? We can do the basic or the standard. So this is where we're going to pick our SKUs, so sizing we're going to use. So if we're working with SharePoint, we're still sticking with that 8 gig starting point. You can go higher. We recommend you go higher, but 8 gigs your starting path into this. So we choose the A3. If it pops, there it is. Choose a username. Click next. Come on. Don't get too complicated, Bob.
So while Bob's learning to type,
Well, it's the English keyboard. It's switched over here from Manc.
this is, for those of you that haven't done this, this is basically just a kind of wizard-driven view of how to provision a machine. It's the most basic, simple operation in IaaS. Those of you that have done it before, you've seen all this anyway. But it's literally as simple as click, 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 fill a few boxes in, and then you've got a machine provision to do with what you like. Bob's going to cover off some of the things that this doesn't do, and why you might not want to do this in terms of how you're going to provision your environments.
So we need to choose a cloud service in here. All right. Wow. Call it Neil H.
So the session I mentioned earlier, by the Victor Veland session, he'll talk a lot more about what these individual boxes are. From our perspective here, it's really just a case of getting something out there.
Choose Northern Europe. And you need to have a storage account, right? So click that. Availability sets, so if you want to replicate these across the different farms or different data centers, we're going to choose that. So you need to create one first before you can actually use that. That's basically it. And from here, it's just going to spin up a new image. Did I just eat up your MSDN?
No,
Over.
that's internal. Come.
One other thing I want to show you also real quick while we're here, and we're going to cover this a little bit. Capturing, right? So one of the benefits here is you can reuse these images over and over again, right? So you build a base image, all you got to do is go and capture it. and then we run sysprep on it, you can use that box over and over again to spin up really quickly. So it ends up showing up in your gallery at that point. Yeah.
Okay. So that was a very, very basic whistle-stop tour of how to do VMs. And again, like those of you that have done it before, it's really simple. You know, you can just keep building them and building them, connect them together, and how it works. But what actually goes on behind the scenes? So when I'm doing this in the UI, or when I'm scripting this, how does all this stuff get allocated to me? How do I get billed for it? Which is something I really want to know, right? So the important thing is, obviously, whether it's in the UI or whether you're doing it through script, first step, obviously, first operation, obviously, is a customer creates a virtual machine. They follow the process that Bob just went through there. At that point, what Azure does is it assigns a compute endpoint. So it takes the information that you've provided and it assigns that endpoint into your subscription. And it assigns basically the provisioning location, what storage it's going to use, what data center you've chosen, what network configuration you might have chosen, if indeed you have. Then it starts to spin this thing up. So what it's doing, it's assigning the ISO image. So the ISO image is basically the virtual image, the base image that we're using as a template for your environment, assigns it to your storage account. And at this point, you start to get billed. Well, when the machine powers up. Once the image is in your storage account, again, as Bob mentioned, we're using standard templated images, right? So this image now becomes yours. So we take a copy of what's in our base gallery, and we basically, it's similar to the capture mechanism, we take a copy of it, we replicate it into your storage account. At that point, we connect that endpoint, or the endpoint for that machine, the management endpoints for that machine, to the actual Azure Fabric, and you can start to communicate with it. And then at the end of the day, we assign what's called the host agent, which is the management agent. If you can think of this yellow box as being a host machine, virtual fabric, or virtual host fabric, we drop the VMs in there. And depending on how you build it, whether you go for one machine, two machines, whether you go for availability sets or replicated storage, we'll start to think about how we assign this information into the actual fabric itself. So behind the scenes, this is like a custom OS. It's a custom workflow provisioning engine that's doing all the work for you. And then when the VM's finally assigned, we assign it to your customer account, and then your bill starts going up, depending on the size of the machine. In terms of the virtual machine storage architecture, I'm going to build this guy out so I don't have to stand here. Go back. Basically what's happening is we've got our base fabric, our virtual machine. We assign an operating system drive. All VMs must have an operating system drive minimum. All VMs get a temporary disk. Mentioned already, don't use the temporary disk for storing data. There is a nice little text file that gets dropped on the temporary disk that basically says don't put stuff here because we're going to lose it. And then you can assign additional disks, so whether they're data disks, different types of storage, Azure files, Blob store tables, whatever it might be. So you're assigning data drives to be used for example, if it's a search server in SharePoint, you want to drop your search indexes out here. And you can attach different types of storage here to gain different types of performance, which is what we're going to talk about as we go forward. Kind of the more interesting stuff. I think this is dead. Okay. Thinking about the disks, I mentioned already, so SharePoint will live or die by performance. Those of you that are SharePoint engineers, if you build it bad, or someone gives you bad hardware, because you guys never build anything bad, right? It's all good. So when you build it, if you build the storage layer poorly, you're going to struggle for capability. When we think about what IaaS offers us out of the box with standard storage, right? These are just regular VHDs stored on regular disk arrays attached to a SharePoint, attached to any virtual machine. So the basic original machines had a maximum of 16 disks. Different SKUs can offer 2, 4, 6, 8. What you needed, 16 was a maximum. And 1 terabyte limit per disk. So up to 16 terabytes of storage per virtual machine. That's reasonable, it's not bad. Generation 1 VHD. But the performance we could get, each individual platter, if you like, or each individual VHD, 500 IOPS max. That's actually not bad when you think about it. That can hit the IOPS requirements for all of your SharePoint workloads. And as you go on, when you start to look at applying more and more disks, so 16 times 500 gives us 8,000 IOPS. We're now into the space where we're thinking about proper, decent storage level capabilities. SharePoint's not always about the IOPS though. So as we go forward, we're going to look at some of the other considerations. Bob showed you something on the brief demo there talking about the concept of a storage account. Storage accounts have these limitations. So a standard storage account on the previous slide was limited to 20,000 IOPS maximum. So you can stuff a lot of data in there, but you're capped at the amount of performance you can get. As we go forward looking at the newer SKUs, So the D5, for example, 64 disks you can attach to a D5. Standard storage times 500 IOPS, that's enormous. But you can also start to bring in the concept of premium storage. Premium storage is dedicated persistent attached SSD. It's not that cheap, but it's not as expensive as you might think. I can deliver 5,000 IOPS per VHD on SSD standards, on SSD premium storage, which is a significant improvement over what we could do before. So within my storage account, I can hit my 50,000 IOPS limit. Why would I have 64 SSD drives attached to a machine then if I'm capped at 50,000 IOPS? And that's the kind of a trade-off you have to make. So within an individual machine that can handle premium storage, you only need 10 of these drives to max out the space. And we're going to show you some metrics in terms of how that works and how that profiles. So a couple of things to think about then. Storage is critical. Premium storage is really a requirement as we start to look at some of the SharePoint SKUs and SharePoint workloads. SQL Server is the one everyone calls out. My SQL Server needs loads of IOPS. Yeah, maybe. Doesn't need as much as search though. Doesn't need as much bandwidth as search. This is where the comment I made earlier about the local SSD. If you've ever done disk performance testing, and some of you that have played with IaaS might have done disk performance testing, and you look at the comparison between your C drive and your D drive that you get on a base machine, you'll see the C drive will deliver you somewhere around 400 or 500 IOPS on a good day. The D drive, the attached D drive, the temporary drive, will deliver you something like 35,000 IOPS. So everyone goes, that's awesome, I'm going to use that. I'm going to put my search disks on there, put my things on there. So as I mentioned earlier, not a good thing to do, because when we reboot the machine, you lose all that data. Another thing to think about, I mentioned already local SSD drives are here. So you don't need to start backing off to this temporary drive, because we've got local SSDs that you can use anyway. Thinking about storage, we don't think about replication. I need the clicker. Okay, so Azure Storage, basically, when we think about VHDs, we're thinking about page blobs. There's different types of blob storage, or different types of storage we can use in a blob store. Page blobs is the one that we use for VHDs. The important thing in terms of the storage that we do, we can connect to this storage in different ways. When we're looking at just pure VHDs, we mount the VHD on our drive, and from all intents and purposes, externally to a user, it looks like a regular fixed disk attached to a drive. Internally, there's some other clever stuff going on with REST APIs to do that connectivity. When we think about replication, as we look at choosing different types of storage, sorry, I need my clicker to control this. When we think about different types of storage, within a region, when you choose a storage type, you can choose different types. I mentioned right back on one of the early slides the concept of ZRS, or zone redundant storage. With SharePoint, default storage is locally redundant. So by default, everything I attach to SharePoint, everything I attach to IaaS, by default, I have 3 copies in my local data center. That gives me that kind of high availability capability, or disk level high availability. But I can do other things with that storage. I can choose to go geo-redundant, so I can replicate all that storage out over here. And that brings in the concept of SharePoint scenarios with replicated storage and replicated virtual machines, which is a whole new topic, which we'll get onto at another point. And someone, Eric Howland, delivering a session talking about that. But the key thing here from an underlying data protection, if you imagine this is your SQL database is attached to a SharePoint farm, you can replicate them using this technology to another location. A few interesting things, I need this to work. Interesting things about disks, they are what we call sparse. So again, we're talking about the base infrastructure here. If I build a VM and I put a 127 gig disk on there, but I only use 10 gig of it, I'm only paying for 10 gig of it. Right? We don't charge you for all of that space, even though we do allocate it. So they're sparse. We don't charge you for that space, and we also recover. As you use a space, we will use this thing called trim support. So as my disk grows, sorry, this is nuts. No, I want to go backwards. As my disk grows, the amount of unused space is being consumed. I've got less unused space, and I'm being paid for that. But then as I free that space up or delete content, we trim back down, but I'm obviously only paying for what I've trimmed back down. So it's just kind of a concept in terms of the Azure implementation, in that you only pay for what you use, you're not paying for what you necessarily assign. Thinking about VM images in capture, so this comes into what the concept that Bob talked about earlier. where we were looking at things like taking a standard image, converting that image into a format that I can then reuse. So if I deploy a VHD, I would deploy a single machine into Azure, I can then sysprep that machine and what's called generalize it for reuse, if you're familiar with sysprepping technology. And then I literally can capture that machine in my SharePoint or in my Azure subscription and redeploy it. So if I want to stamp out lots of SharePoint farms, if I'm a hoster, for example, I don't want to stamp out loads of these things the same. So I can use that capability. And this gives me the option to deploy tons of Linux machines everywhere. So I can drop as many machines as I like, every single one being absolutely identical. And we provide that capability for you inside the Azure infrastructure fabric. Something Bob mentioned when he was doing the deployment was the concept of high availability within the data center. So he talked about an availability group. And things get kind of interesting here, especially when we think about SharePoint. Within SharePoint, let's think about Office 365, right? The way we deploy Office 365 stamps in our own environments inside Microsoft, and the way things like the PLA guidance talks about deploying SharePoint is using layers of technology. So using like the concept of a standard web front end role, the concept of a standard application layer role, the concept of a standard search role. And that kind of gets interesting when we start to look at availability sets. Here we're talking about SQL, but if I wanted to do, for example, a high availability set inside Azure that I knew was guaranteed that I would always have minimum of 99.95% availability, this is your friend to make that happen. So I can deploy 2 machines into an availability group. And I know that if one of those, well, the way we distribute those machines, which I'll talk about in a few minutes, we make sure that whatever operational work we're doing inside Azure will not affect both of those machines at the same time. So you hear stories about Azure outages and things like that. We will guarantee if you put 2 machines in availability set that no one single host server has got both of those machines on, that no single network fabric connection is going to both of those machines. So we provide that layer of layer of availability. It also means that when we patch our own OSs, so of course we have an operating system sat behind the infrastructure that you deploy on top of IaaS, we also guarantee that we'll never reboot 2 machines at the same time that have your stuff on. So we'll never patch them together, we'll never reboot them together. And the way we do that, if you think about what you have physically, inside a rack here, just showing an example of a single rack with 4 machines in, which you might come across very commonly in an on-premises scenario. Same kind of idea with a a power switch or a network switch. The problem with this environment is our fault domain, if you're familiar with disaster recovery terminology, is that rack. We're basically down if that rack goes down. The way we fix that in terms of our availability groups in Azure is we do distribution. So I mentioned already about the availability set. So with our availability set, we have, when you drop 2 machines in there, as I said already, we will guarantee that those machines are on different infrastructure. And if these machines, the back-end hosts for these machines, I said already, ever rebooted, we won't reboot the other one till that one comes up. And you can distribute things like that. It's similar, if you're familiar with the kind of concept of PaaS roles and worker roles and web roles, it's a similar idea to that kind of concept. So as I said already, if VM2 goes down, or if the host machine hosting VM2 goes down or is patched, we won't patch the other one till that one responds. And we can take care of a bunch of other things, not just availability groups in terms of making sure that the machines are online, but what about making sure that the services on those machines are online? So what do we provide to give you that high availability? If you're on premises, you might use Windows Network Load Balancing. You might do it properly and use an F5 or some other appliance-like device to do your high availability. Typically with SharePoint machine or with web-based machines in IaaS, we can do this thing what we call load balance sets. So we can start to introduce the concept of an internal load balancer inside the Azure fabric. And the internal load balancer can do a bunch of things. You can get quite complex with it. Fundamentally what we're looking for is it to do 2 things. Distribute my traffic and check that the sites are available and distribute the traffic to those available sites. And we can do it based on things like the concept of the public port. So if I'm publishing to the outside world, I can have my load balance level there when I think about using either internal or external load balancing. I can do it internally. So if I'm offering services on a group of VMs to other VMs that I'm hosting there, I can internally load balance those as well. And we can do it through the kind of things you'd expect. We can load balance on name, we can load balance on protocol. And we can start to introduce ACLs on the load balancer as well to restrict traffic around, to restrict where traffic goes, to restrict who can actually access certain machines within that load balance set. Very straightforward, standard load balancing. If you think about what this is actually doing, here's my application, sat on 3 VMs, could be 3 SharePoint web front ends. I deploy my Azure load balancer here, and all I'm doing is saying, endpoint, use port 80. I hit that endpoint, the traffic is load balanced across these sets. And there's different ways to do load balancing. As I said already, you can do, the concept of health-based load balancing. You know, if one of these machines goes down, for example, you can do health routing to make sure the load balancer doesn't distribute traffic there in the same way you would with any other environment. You know, if you're using a complex external load balancer from a vendor or something, you can do the same thing. You can put probes on so that we're probing the protocols. We check whether page is responding. We check whether machines are responding. And generally, from the Azure perspective, if it's a load balancer for HTTP traffic, all we're doing is very simple. We're looking for a 200 response of a port. That's all we're looking for. But it gives you a very simple and easy way to deploy highly available solutions. You know, if you go with the availability set, your machines are not going to get rebooted at the same time. You know, we're guaranteeing you 99.95% availability. You know, if you go with a load balancer, you can start to look at things on your own VMs, and if you start doing maintenance on one of the VMs, the service won't go down because the load balancer with the health check will take care of that as well. So we're giving you kind of belt and braces availability there. In terms of how we can deliver load balancers, so there's basically 2 ways. If you think about your on-premises environment here, obviously Azure and IaaS, if we think about the concept of a publicly available either SharePoint or web application, we can do the concept of what we call the external load balancer. So in this case, I've hosted a load balancer. I'm hitting it externally through the internet, and my load balancer is listening out on my port 80 endpoints, or whatever port it might be, 443 ideally, and it's load balancing that traffic coming in from the outside into my fabric. The other alternative, which doesn't show too well, there is a blue circle here that you can't quite see, I don't think. If you consider that the customer network may well be attached internally to Azure via a site-to-site VPN or via express route, then we have the concept of the internal load balancer, and in this case, we're excluding all of the internet piece on the outside. We're going straight through an internal network connection to our Azure instances, and we're load balancing internally instead. It's the same concept, you build it exactly the same way. It all depends on where the endpoints are. Are they internal, as in people are already, the Azure network is effectively an extension of your own on-premises network, or are they external, as in you're publishing out to the internet? That's the kind of key thing. Just thinking about those features then in general, concept of load balance set and availability set gives us 2 things. Availability sets gives us this redundancy at the hardware level, and then the load balance set gives us redundancy at the application level. So if you're building SharePoint, again, this is kind of common to any web application, if you're building SharePoint, make sure you distribute your roles. You want, if you've got 2 machines hosting your search index, they're both hosting, everyone's familiar with SharePoint, right? So partition 0, and you've got two replicas of that partition, then you want to make sure that one of them is over here and one of them is over here. So if I lose this one, my search carries on working. Same as if it's a web front end, same as if it's any 2 VMs hosting a SharePoint endpoint, a user profile service application endpoint, or something similar. So we give you that kind of ability to have ability to have host-based and individual machine-based high availability. So I'm just going to show you how you set those up. If you haven't done it before, go back to the portal where Bob was. And all we're doing in here, if I look at an individual VM, so if I look at, I don't want to break that one. If I go to a VM that's running, did you build that VM? You did.
I think I did.
So when I look at doing the endpoints here, so by default, it's not the biggest, a little bit better. So by default, when I provision a VM, I get 2 endpoints. I have a PowerShell, so I can do remote capabilities and attach PowerShell and work with the machine through PowerShell. And I get my RDP, my remote desktop endpoint. What if I wanted to have another endpoint in here? So if I could put like port 80 in here and load balance it, all I would need to do was add, and I could add a standalone, I don't have an existing load balance endpoint, What I could do is, I could do port 80, and I'm just going to keep this simple. Obviously I can route to a different set, and I can create a load balance set, and that'll go through, give it a name. I know this is going to break, and you can see something in here. So what I've done is I'm basically saying, create me a load balance set, including this machine and its port 80 endpoint. Here's the protocol I want to use. This is the probe I want you to port, so the port I want you to probe, and this is the interval I want you to hit. So I'm basically going to start hitting those machines included in the load balancer. But I've only got one machine in there, right, to start with. And that's going to go away and do its thing, and it'll work to add that endpoint. Once I've added that endpoint, I can then start to look at adding more and more machines. Do you have a question?
You have a number of probes and intervals.
Yep.
Does that mean every 15 seconds, two different...
Every 15 seconds there'll be 2 probes against that machine. Yeah.
Is 2 a good number?
Two's the default, 2's fine, to be honest. Every 15 seconds, depends on your SLA, right? If you're expecting 5-second termination of an endpoint, if the machine goes down, then you need to reduce that number. So that's basically how we do endpoints. So what I could do is now go to another machine and then choose that and then add the endpoint, do the same thing again to make it. I haven't got 2 machines here that I can risk breaking because of other demos, but let me have a look.
Do the 2 machines have to be in the same storage account?
So the question is, do the 2 machines need to be in the same storage account? No, they don't, actually. The only thing you need to do, they need to be in the same cloud service. So their endpoints are connected in the same service, but they don't need to be the same storage account. So again, I could go to another machine here. I'm not going to add this one because this could cause me some problems, but basically I could add to an existing endpoint. It will show it me. No, this machine's okay. This machine's in a different service, but you get the idea, right? If I went to a machine in the same service, so if Bob had built me 2 machines instead of 1, I could have gone in and provisioned it. So I would just add to an existing endpoint. That would automatically put that machine behind that same load balancer as the other one. And I end up with 2 machines, load balanced. If one went down, the traffic would continue to be served to the other one. In terms of availability sets, that's a little bit different. So if I go and look at a machine down here, so I'll look at this web one. In terms of if I configure this guy, so this is a pre-built SharePoint on Azure environment that I think I'll probably show you. Excuse me. Do you want to just kill them all? In terms of availability set, what we've defined here is when you create a machine, you can define the availability. So I'm going to put this machine into an availability set. The first machine in the availability set obviously gives you nothing, right? It's one machine on one host, doesn't go anywhere. And if you have a failure, I'll just let Bob break my environment again.
Why that pop up?
Okay. In terms of availability set, so in this scenario here, I've got SharePoint on Azure, Web Machine 1, SharePoint on Azure, Web Machine 2. The fact I've got this availability set now for these 2 machines now tells Azure that within my subscription, each of those machines will be hosted on completely different physical infrastructure. So I'm building in that, as I said already, that kind of machine level redundancy to make sure that if the host box that's hosting this machine gets rebooted for some reason, maybe we do OS patching or is a failure, then the other machine won't go down as well. We'll guarantee that that second machine will stay up within the bounds of what we can control. And that's how we do availability sets. So you just add the machines in. So I can drop machines in here. And if I provision a new machine, I can add it in again. So if I need a lot of compute power, if I have a huge search platform in Azure, I'm not saying you should do that, but if you did, then you could put your availability set with multiple availability sets for all of your different partitions so that each partition always had at least one machine online. So you could kind of maintain that capability. So the next thing, really thinking about IaaS, and SharePoint in a way is is affected by this, but also it affects a lot of other things as well as just SharePoint. When we're thinking about how you build your environment and how you connect to that environment, Bob's going to talk through some scripting, a little bit on scripting later, I think. But when you think about how you build and connect, we're really thinking about where do you position the machines, how do you connect to those machines, And how do you domain join your machines? So am I going to domain join machines to my on-premises network? If I do that, I need to build infrastructure to allow that to happen. I'm not going to do that over the internet, right? I'm not going to publish my domain controllers out to the internet. So I need to think about splitting up the environment into different subnets, maybe into private IP addresses, splitting up ranges and providing ACLs on those ranges. So it's too complex a subject to get into right now, but I can subdivide my network to make sure that I can only communicate with different layers. And I think Bob's going to talk about that later. But when I think about the connectivity in terms of data centers and connectivity to on-premises, there's basically 3 solutions I can use. So I don't want to go over the public internet if I'm with this environment. I want to connect my own on-premises environment to Azure. A couple of ways you can do it. So the concept of a PS2 connection, so a point-to-site connection. So I'm thinking about maybe a remote worker. This is my Azure environment out here. I have an application, might be SharePoint, could be something else. And I have a gateway definition here. The gateway is simply like a VPN gateway, if you're familiar with that technology. And all I'm doing is allowing basically demand dial, or I'm allowing on-demand dialing for users to connect to that point site and connect to the solutions inside the Azure cloud. Or I can extend it and I can do site to site. And this is probably the most common that we see when people are extending their network into Azure. The session that Manas and I are going to do this afternoon, we do this. We actually go through this process. So we talk through extending an on-premises VPN machine, which could be just a Windows server running IaaS. It could be an appliance, Sonic Wall or something like that you've got running on-premises. And in this case, you're connecting an entire routed network. So all of these machines, they could be all of your clients, they could be other servers, there could be domain control or replication traffic, and you're replicating between both environments. So you've basically extended your network out into Azure, making use of the Azure high availability, the Azure capabilities out there, but fully accessible from on-premises, subject to restrictions you can put in here in terms of who can access what machines, the usual kind of permissions you might put in on-premises for access to services. And then the final one is probably the newer one, and we GA'd this fairly recently, is the concept of ExpressRoute. Is anyone using ExpressRoute or played around with it? No? So ExpressRoute is basically, it's almost, apart from the network admins, to an end user, it's effectively transparent. And it's very, very high capacity. So what we've done is we've partnered with a number of global network providers. And if they're offering you their service as an ISP, they effectively push you through here a multi-gigabit bandwidth connection from your on-premises environment into Azure, as opposed to the VPN connections, which can be limited to about 100 megabit. So if you need that kind of really closely joined, super high power, super high bandwidth connectivity, you can go down the ExpressRoute option, route option, Americans. So it does become a seamless transition. It's very, very high capacity. As you can probably guess, it also costs a lot more money, right, as you'd expect. So with that, I'm going to let Bob talk a little bit more about, specifically about SharePoint on Azure, and then I'll come back to some of the storage metrics and capacity planning guidance around storage and SharePoint and what you need to make SharePoint work properly.
So as Neil was mentioning, as far as a production farm goes, it's usually better off going with the dev and QA farms. And so as an engineer, field engineer, how many of you guys got QA farms, test farms you're working with? Nice, thank you. It's very rare. Back in the States, we've had a lot of issues where folks just don't do that. So all their dev and test is done on prod. It's not a good option, right? So, especially for the devs. So this is a perfect solution for doing that inside of Azure. I'm going to show you how to spin up some really quick farms, but I'm also going to show you a script that we use. And we've got another session later on that we can fall back on. He does an end-to-end script. Who's that, Wick? Wicker, yep. So the cloud host, the cloud app model, again, we got, neither one of us are devs. Well, he's a dev now. He passed the test. But Vesa and those guys are doing another session on that, so I definitely recommend you guys go see that guy. So SharePoint farms on Azure, you want to determine the best authentication configuration. Right, so we still got our basic NTOM Kerberos, but we're getting some more other areas with Active Directory. Creating your virtual isolated networks and storage points, which we just talked about, very important. And I'm going to explain why you want to use a script to do your installs. So we'll show you the easy method, the admin method, push. And we'll show you the script way, which is better. Creating your SQL servers with better performance. So, how many SharePoint admins are in here? So what's the weakest link? SQL.
SQL admins.
Well, any SQL admins in here? Good him. Right, so that's usually the single point of failure when we're going to like crit sets, or if we're doing RAS engagements or RAP engagements. One of the first things we do a perf test against SQL. SQL suffering, SharePoint's going to suffer, right? So we want to make sure when we are building on our farms and we're using SQL, we make sure we build as powerful as we can, get as much IaaS out of there. We're doing a session U.
Yep.
Manas, is it next, or is it?
3 o'clock.
Yeah, so they're going to do a deep dive into this area. We're just going to cover this lightly. So corporate Active Directory, separate Active Directory with Azure IaaS. Moving into the Active Directory, so ADFS. We do support ACS right now. We're all moving over to ADFS at this point. So we're just going to show you the separation here. So one of the things we're going to show you is if I build out a farm using the UI, one of the things I can't do is I can't create a separate subnets inside here. All right, that's got to be done through a script. All right, real easy to build these out. We've got some pre-configured ones. If you really want to build a good test farm that's going to mimic your on-prem sites, you want to do it through the script. You want to touch on this one at all?
I can. Yeah, I mean, so the point I was making earlier about isolated virtual networks and about things like availability groups and separation, here's where you might start to look at cascading these things around. So web front ends all in one group. Think about putting availability sets across there. Again, with your domain controllers, we're offering, I think this week, PowerShell conference is this week in the States somewhere, and they're publishing a whole bunch of DSC templates for a whole range of services, including Active Directory. Victor will touch on DSC later, but in terms of separation of layers and communication, we want to build out a templated infrastructure that allows us to restrict the traffic going through here, restrict the traffic going through here, and make sure, like you would with any kind of regular on-premises or perhaps extranet-based solution, you want to restrict those ports and restrict the protocols that people are allowed through. So separation means I can put these in different virtual networks, I can have different levels of connectivity between them, I can put different levels of access control on those environments. So if I wanted my SQL admins, oh, it's Brian, hey Brian. So I wanted my SQL admins separate from my SharePoint admins, at this layer here, I can put network security groups in. So only my SQL admins can go, my SharePoint admins can connect to my SharePoint boxes, only my SQL admins can connect to my SQL boxes. So I can have that kind of level of separation and control. You got this one? Has anyone gone through the wizard of building a SharePoint farm in Azure? Doing the click, 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 click thing? Yeah. You like it? It work? Did it work? Was it successful? That's a different question, actually. Is it working?
Compliment my last demo we did. You notice we did it through here. So this is a new portal we have. So I'm basically doing the same exact thing I just did in that one inside this one. I'll show you the difference.
So to Bob's point earlier about dev and QA farms, this is a great solution for a dev farm or a QA farm.
Really, really quick. So I go inside here.
You got it? Yeah, you're there.
So I can search everything. I can just drop down to SharePoint.
So the thing I mentioned about the templates before, this is basically a templated approach to view things that isn't working very well, Bob.
Did I spell that wrong? Did I spell that wrong? Or is this just not working?
We've got an Azure outage. You in the right place?
Yeah.
Well, if this was working, in the interest of time, we should probably go quickly, but what basically, if you, inside the marketplace, inside Azure in the preview portal, you can spin up a whole range of different things, different services and capabilities, one of which is SharePoint. Yeah, shortcut, there, go there. Here down there, the Azure Marketplace. So 3,000 possible solutions, all pre-built, all pre-configured, ready to go. You just fill the boxes in, fill the wizard in if you like, and it builds it all for you. The high availability set, the load balance set I was showing you earlier, was part of one of those solutions, a SharePoint solution. So we can deploy kind of 2 SQLs, 2 app servers, and 2 web servers to give you a kind of high available deployed SharePoint farm. You found it?
Yeah, well, either way, I mean, that's the other way to do it. The way we recommend doing it is through a script. All right, so I'm going to show you one. Again, we got another session later on. I highly advise you guys go because it starts from the very beginning of building this, even to the SharePoint farm, which is really what you want to do with these guys. So what we do here, one of our PFEs built this. It's a real simple script. We plug in our variables, but what this does, it goes through and it'll actually spin up your DC. It'll join the boxes to the DC. And it'll spin up 4, 5, 6 boxes you want to throw inside your farm. All right, so your typical test farm we use is going to be 4 boxes. So a SQL box, AD box, 2 SharePoint boxes, just for basic testing, right? Doesn't say you can't put in more, right? You can put a lot more in there. This is a quick and dirty way of doing that. You just basically run this, you walk away, you come back an hour later, everything's done for you. So, real nice solution. What Neil was talking about with the separation is, let me find that. Oh, you got it right there. Yeah. So what we're doing here, what you can't do inside the UI when you're spinning these up, you can't choose those subnetworks or those VNets. This right here will go through and run that. All right, so it'll go through and create these. So this is going to give you your separation, right, in your networks. That picture we were just showing, that's basically what this is doing here. Now, this is publicly available, this script. There's about 7 scripts inside there, but it's a real simple thing we can do. Joe Rogers, do we have him listed on here? Joe Rod?
No, but if you want a link for these scripts, we can
Yeah.
give you them.
But again, Wicker's going to have one also, and I'm sure he's going to have that listed also on the site, so real quick. Yeah.
Okay. Yeah. So the reason we didn't run those scripts or run that wizard, well, the wizard we couldn't find it. It's American English. But if you find the wizard, if you've done it, I would suggest give yourself the opportunity to go through that process. Spin up a free MSDN or trial Azure account and just go through that process just to give you familiarity. Because while it's not an ideal, well, not a capable for production SharePoint environment in IaaS, what it is an environment that's provisioned using a lot of techniques that you will want to use if you go ahead and deploy SharePoint in IaaS, like the availability sets, like the load balancer, like the distributed communication and the different virtual networks, different cloud services. So there's a lot of learning experiences in there. The stuff I want to go through now is really the concept of, go back one, of looking at, so if I'm building SharePoint, what do I really need to think about? What do I need to make sure I do right? What do I need to make sure, more importantly, I don't do wrong? Because if I go down one route, I might not be able to back out of it. And when we think about SharePoint and performance, there's a couple of key things that we've noticed in our testing, which is probably very similar to what you have on premises, that actually affect the way SharePoint behaves. Now, we're talking to one of our architects, Uli Holman is the chief Azure architect. His take on the scenario in terms of deploying SharePoint on IaaS is very straightforward. If I can buy a machine on premises that has 8 cores and 14 gig of RAM, I can deploy SharePoint on there, right? If I can do that in IaaS, why can't I deploy SharePoint on there as well? And it's not quite a simple equation like that. There's more to it than that when you think about IaaS. We need to think about some other things. Things behave differently. So this is a classic example. If I look at trying to skimp, okay, I'm not supported here, right, for SharePoint. I'm outside of my support boundaries in terms of number of cores, amount of memory. So the bottom machine, the A4, is actually the minimum supported boundary for SharePoint. This is achievable page load time in IaaS using standard infrastructure. Nothing special, no premium SKUs. I can get my page load time down to like, what's that, no more, well, 5-second peak perhaps. That's pretty good, right, for a single machine. Cost, £164 a month. Compare that to the cost of buying a machine, running a machine, operating a machine. I can do pretty well with some of these smaller SKUs. 200 users, okay for most companies, not great for enterprises. As I start to think things going bigger, I need to get more clever about what I'm actually building. I might need to think about building enormous SKUs. So what about these guys down here? Our D4s and D14s. Recently, the customer I was talking about earlier who built this temporary environment and put all their search indexes on the temporary disk because it was fast, not realizing that they were about to lose it all if we rebooted the host. Their option is now to go down here with these kind of machines, because DS class machines we can attach premium storage to. But what you can see in terms of a SharePoint deployment, if I need that level of power, I'm suddenly pushing my costs out significantly. Right? VM costs on Azure will go down over time, as all things do. But right now, if you want to build a machine in Azure that's going to perform the way a machine on premises will, and give you that capability in terms of page load, search experiences, and stay within supported capacities, you really need to start thinking about these bigger SKUs, and they can cost a lot of money. As we go even bigger, look at this guy. £4,000 a month for one machine, right? 64 data disks, max IOPS 64 times 500 on standard disks. Can we actually do that much? Probably not. We can introduce load balancing, we can have auto-scale, but look at the size of the thing, right? That's kind of the extreme end. Going from there forward, we can start to look at other things in terms of not just how big we want to go, but where's that sliding scale and where's that sweet spot for us? The true answer is, the sweet spot what you build in terms of the machine SKU will depend entirely on what your workloads are, entirely on what your capabilities are and what your requirements are. Other things we can do in terms of performance metrics. So from a SQL perspective, the temp drive, this thing that gets blown away every time I reboot a host, I can put my temp drive on that non-persistent, my temp database on that non-persistent disk. That works very well. It's a fast disk. It's temp DB. If I reboot the machine, I rebuild the temp DB anyway. So why do I care if it gets blown away? But how do I put the disk there in the first place? So we need to think about that. So one way we do in terms of in MSIT is we have this very, very simple script, which isn't going to load. So Bob broke my environment. I'm blaming Bob. Let it load. Tell you what, I'm going to come back to that. Let me wrap the slides up and then I'll come back and show you the script. I'm just conscious of your time. In terms of SQL performance then, it's SQL performance, but it's also thinking more about core storage performance. As we look at the different levels of IOPS and capabilities that we have, I mentioned on the previous slide the concept of using things like storage spaces. So storage spaces is a Windows 2012 R2 feature. I think it's R2, not just Windows 2012 and R2, which allows you to bundle separately attached disks to a virtual machine or to a machine into larger storage groups. So I mentioned already, with the 500 IOPS per disk, bundling multiple disks together. So I can create big LUNs and I can do all kinds of things. This is just some basic testing in terms of IOPS. If we look at simple things like, testing different block sizes here for retrieval, storage spaces in terms of IOPS versus standard disk, I get a huge improvement in performance. So I'm pushing my IOPS now up towards that 2,000 IOPS limit. That means I can store bigger content databases on there in terms of SharePoint World. From a throughput perspective, we're still struggling. Anyone know what the minimum throughput is for a search indexer? Manas? No. So the minimum requirement for a search indexer for SharePoint is 200 megabits per second. Right? Supported limit. Can I hit that with standard storage? Not a chance. I'm not going anywhere near it. So I now need to start thinking about storage and premium storage and persistent SSD for that kind of capability. Storage spaces and latency. Standard latency on an Azure disk, 16 milliseconds. Put a storage array in, storage spaces array in, and I'm now down to 4 milliseconds. So just by moving my storage from direct attached to the machine to a storage space array, I can significantly improve what I want to do. A couple of other things you can look at for the SQL Server admin in the room. Using SQL Server XI storage. Anyone played with that at all? So we're now talking about a scenario where I'm using Azure Blob Store. So I build a container in Azure Blob Store and I use it to mount my VHDs directly into. Okay, we're not going from on-premises to Azure Blob Store, but I can take a container, an Azure Blob Store container, and it can be premium storage and deliver me 50,000 IOPS, and I can start to just provision my databases in there. SQL Server 2014 supports REST API connections to storage, so I can use that capability. I can significantly enhance what I'm doing in terms of getting that ability in there. You mentioned already about using log disks down there, but I mean, a few other bits and pieces that's improved if you go down this route. So when you attach a disk to a SQL server in IaaS, how does that communication happen? It goes from the VHD through the host machine down to the blob storage level and all the way back again. If I go down this route of using SQL Server XI storage, my VM is now communicating directly to the NIC. So I'm bypassing one level. Sorry, my VM is now communicating directly to the blob store. So I'm bypassing an entire level of latency there. Thinking about capabilities and bigger machines, I mentioned already about different sizes of machines. Premium storage is not that much more expensive. Depends how much you need of it, of course. Standard storage, £1.47 a gig for 100 gig. Premium storage, £5.47 for 128 gig. Okay, it's four times more expensive, but in the grand scheme of things, it's not thousands of pounds, right? It's premium storage is relatively cheap. The problem comes in as we start to look at the machines, because machines, you need to provision DS standard machines to support premium blob storage accounts, and these now start to ramp up price-wise. But we can deliver an awful lot of performance. You might find you need 2 of these machines versus 10 of those other ones. Put them in an availability set, load balance them, you're guaranteeing your uptime while still provisioning fewer and fewer machines. And the amount of IOPS I can hit, 12,800 IOPS on this machine with 8 attached disks, 28 gigs of local SSD, of RAM, sorry. As I go forward, I can go to bigger machines again, and then I can go even bigger. So I'm now looking at the scenario with the DS14s, 32 attached disks, 124 gig local SSD, and 50,000 IOPS. That's the spec of machine that we run Office 365 dedicated on in a hardware device, not an Azure device. So you can build the same SKU, 112 gig, 16 cores, £1,000 a month. It's not bad, really, for an enterprise. Small business might not want to afford it, but for an enterprise, if I could drop 2 of them in, instead of like 10 machines on premises, and all the network gubbins that I have to deploy on premises as well, I'm starting to introduce the potential for cost saving, as well as the potential for the fact I've got a machine in Azure that I know is guaranteeing my uptime. I know Azure will take care of it, and I know if they don't, they're going to pay me back my money because we have SLAs on against that kind of thing. So those kind of things you can do very easily in Azure. We never had these SKUs before, which is why SharePoint was never ever on the table before. It was never a discussion you would ever have had with any customer to say, put SharePoint in IaaS. Now, we're starting to see realistic possibilities. Potentially expensive ones, but realistic ones. Just looking finally at the kind of comparison between the storage here. If we look at, if you can read down the bottom, the 2 lines, or the lines we're looking at here is in terms of latency, bandwidth, and IOPS. We're just looking at a comparison between premium and standard storage, so it's similar to the graphs we saw earlier. Looking at the capabilities we have, this top brown line here is premium storage IOPS. We look at the types of connections we're doing. So we're doing different block size calls here, but you can see we're running at about, where are we? We're up to 35,000 or so. Sorry, IOPS is the blue bar. Apologise. So this is a test I did. I got to like 43,000 IOPS. That was on 10 attached disks. So in potentially 50,000 IOPS, a little bit of overhead. So I managed to get to 43,000 IOPS on these drives, compared to premium storage with the same capabilities, very low. Okay? We start to look at things like bandwidth. So I mentioned SharePoint requires that 200 megabits per second bandwidth capability for its indexers. It's a minimum supported requirement for the disk capability of an indexer. Standard storage, down here, this is actually not bad. It's going quite high, right? Well, the block size is really high, so we're up to like 250 at this point. But compare it to premium. Premium is bursting everything at like 500. Okay, so we're getting significantly higher bandwidth capabilities, throughput. Basically, the speed that the VHD can, or the speed that the VM can read the information off the disk. We've got bandwidths now. We can seriously start to think about SharePoint. And again, network latency in terms of the latency response on the disks. They all do pretty well. As you start to get, you'll start to see the next table, which I think is pretty much the end of the session. We'll show you the the kind of numbers that map to that table, so to that graph. If we start to look at our bandwidth SKUs, one thing that's very obvious is we don't seem to be able to get over 500, and that's currently an Azure limitation. 500 megabits per second on premium storage is as far as you're going to get. We have quality of service limitations on it. Same with standard, it's around about the 200 to 220 mark. This is a nice sweet spot. So 32 disks, reading 8K block size. SQL admins might not be happy with 8K block sizes, but you never know, maybe they are. And then when we start to think about the IOPS we can deliver on premium storage, the bandwidth we can deliver meets our requirements, and the latency, more importantly. Very, very low latency, enough bandwidth, and significantly high IOPS. So we can start to think about that class as being kind of the sweet spot for a potential SharePoint deployment. And it's what you decide you do. You might find that people are deploying stuff out here. They're getting enough IOPS, they're getting garbage bandwidth. Okay, they're not delivering the capability, even though the disks looks like it's running really quick. And latency is poor. So I'd suggest if you're going to do any of this work, do your own testing, play around, use these numbers if you want. They are real, they're off real SKUs. That machine, the machine I'd tested this premium storage on was a DS14 with, like I say, 10 SSD drives and 22 standard drives attached to it. And we did all this testing on there. This is real. So kind of just as a comparison, as a summary, what we're really looking at is standard disk drives give us this kind of limitation, 200 megabits per second. Premium storage, 500 megabits per second. So we can do SharePoint for real here. Bear in mind the cost. High IOPS isn't always what you need. Yes, for SQL, great. Everyone talks about SQL and how many IOPS per megabyte or gigabyte do I need on my content databases. That's not always critical for SharePoint. Think more about these things. Massive IOPS and rubbish bandwidth and latency, you're still going to kill your environment. Okay, so you've got to think about that sweet spot, and Azure has got those sweet spots all around it. It's all about finding the spot that's right for you. So let me show you that script very quickly. If that machine's connected, it has. So this is a very simple script. If I show you the disk configuration on this SQL box, it's a very basic configuration. There's nothing special going on here. All I have is, a C drive. I have my temp storage drive, which is my non-persistent disk. I have a data drive and I have a logs drive. Basic SQL implementation. If I look on my persistent or my non-persistent drive, I have this SQL temp folder, and in here I have my temporary databases. And all I do with SQL to make that happen is I've configured SQL to store its temp DB in those locations, a simple alter statement, or when you install SQL you can do that. And then all I do is run, I have this script here, which hopefully you can see. There's a lot of green in there because I've commented it a lot out, but all this does is my SQL servers are all set, and I have all my Azure SQL servers set like this. They're set for manual start, so they don't auto start. This script kicks in, and it provisions me a folder on the non-persistent drive where I want to put my disk. It sends me an email if I activate these blocks. It will send me an email if it's unable to do that. And then I start the service, and it will send me another email if it couldn't start it. And equally so, I could tell it to send me an email that it could start it. So it's very, very simple. It's literally, if you take all the green out, it's like 4 lines of code. And it just starts SQL for me. And it provisions my temp disk, the database that we want the performance in for SQL, to have the maximum capabilities I can give it without storing it out on really expensive storage, put it on the persistent disk, on the non-persistent disk. Again, these scripts are basically public domain. If you want them, I can give them to you. There's nothing overly complex about them. They do work, though. I notice a significant difference. Significant difference in terms of SQL performance by not just dropping a VM in Azure and having everything on the C drive, for example, or even having it separated into standard storage. That's not necessarily good enough. So the important message really is SharePoint is getting there. It's got a long way to go. That's true, absolutely true. We've got a lot of stuff coming down the line. We've got new versions of Resource Manager coming out with custom plugin templates for SharePoint. That's all coming down the line, announcements. Expect to see some announcements at Ignite. Storage is always critical. SQL we know about, everybody talks about SQL as we've said, but think about your search indexes as well from a SharePoint perspective. And potentially your crawlers. Your crawlers are very heavy in terms of disk usage if you're highly search-orientated organization. And separate over standard and premium storage. So what I'm basically saying there is, use it all, but if you can use standard for most stuff, do so. Storage Spaces has an awesome feature that allows you to plug both SSD and standard disks together in one array, and it will optimize the array so that it uses all the SSD first, and the most frequently accessed files go to the SSD first. So you can make use of that capability to build very large arrays, like the array I built had 10 SSD drives, all of a terabyte in size. The array itself was 32 terabytes. So I had like 10 terabytes of SSD and 22 terabytes of standard storage. And the storage spaces, the way it performs and the way you get better performance out of it is because it cascades the reads across all the SSDs first. It prioritizes your traffic access. So with that, I think we're out of time and we're done. Thank you.